Sutton here, bringing you the IM341 Extra Practice Number 2 solutions on solving by factoring. There's a puzzle that goes with this one. Let's check that out. So here's the puzzle that goes with this extra practice. In this one, we have to basically solve each of these equations and then find the answers down below. And when we find the answer, we'll just put the word that goes with the equation down below that set of solutions. And it'll all spell out some catchy phrase that'll, they said keep working and you will get a moving fact. All right, let's see what that moving fact is. Come on. For our first equation, we have x plus 3 times x plus 8 equals 0. Now, for all of these equations, we can use the zero product property, where if we have something that's already a product, already factored, we can set each of its factors individually equal to 0 and solve them. Because if I zero out one of these factors, 0 times whatever the other factor is going to give me 0. So I can write this as x plus 3 equals 0, and also x plus 8 equals 0. So again, solving either one of these will solve the equation. So for the first one, I subtract 3. I get x equals negative 3. I subtract 8 over here, so x equals negative 8. And I look for negative 3 and negative 8 down below. That's here, top center. So I'm going to put the word y down there. For this next problem, since this is already factored, I can set x plus 4 and x plus 11 both equal to 0. Solving each of these, I get negative 4 for the first equation, and then subtracting 11 gives me negative 11 for the other one here. So that's going to be a negative 4, negative 11. That's over down here in almost the bottom right corner. So that's going to be the word the going down there. For number 3, I can set x minus 5 equal to 0 and also x minus 2. Adding 5 gives me 5 for a solution there, and adding 2 gives me a solution of x equals 2 for my other possibility. So 5 and 2. That's down here, so that's going to get the word is. For number 4, let me set x minus 1 equal to 0 and also x minus 6 because these are still already factored. So adding 1 gives me 1 for an answer. Adding 6 over here gives me 6. So I have 1 and 6, which is down here toward the bottom. So that's going to be the word have. For number 5, let me set x plus 3 and x minus 7, each individually equal to 0. So now I have to subtract 3. That gives me x equals negative 3. And here I have to add 7, giving me 7 for that answer. So negative 3 and positive 7, where do I see that? Right here. So that's going to be the word always going there. For this one, I'm going to set x minus 12 and x plus 5 both equal to 0. Adding 12 gives me 12 for an answer. Subtracting 5 gives me negative 5 for an answer. So 12 and negative 5, that's right here, which is the word that. This next one is almost so easy it's hard. We have to set each of these factors equal to 0. Setting the first factor equal to 0 literally just involves writing x equals 0, which already solves that equation. No sooner stated than solved. And then x minus 9 equals 0 as well. So adding 9 there gives me 9 for that answer. So 0 and 9, I see that right down there. That's going to be the word to. For number 8, they're upping the ante here. We have not 2, but 3 different factors. And the good news is we can set each of them equal to 0. Setting the first thing equal to 0 just literally gives us x equals 0. So that's nice. And then we have x plus 14 equals 0 and x minus 1 equals 0. Subtracting 14 gives me negative 14 as one of my other answers, and then adding 1 over here gives me my third answer of 1. So we have 0, negative 14, and 1. Let me see if I can find those. All 3 of those are right down here, bottom center, so that's going to be the word they. For number 9, I have the factors 2x minus 1 and x plus 4 that I am setting each of those equal to 0. So let me solve this first one. I have to add 1 and then divide by 2 to get x equals 1 over 2, or 1/2. And this other one's a little easier, just have to subtract 4. So I have 1/2 and negative 4, which it looks like is going to give me, where do I find those? Right there. So that's going to be is right there. X minus 2 and 3x plus 1 equal to 0. So there's my first factor, and now the other factor. For the first equation, I just have to add 2, and I've got x equals 2. That was pretty straightforward. This next one, I'm going to subtract 1 first, and I'll divide both sides by 3 to get x by itself. So this is going to be x equals negative 1 over 3. And 2 and negative 1/3, let me find those answers down below. Looks like that's actually the very first set of answers. So I'm going to put a "the" right there. For number 11, we're going to set x minus 10 and 4x minus 3 both equal to 0. For x minus 10, I just have to add 10 to both sides, so that's x equals 10. For the next one, I have to add 3 and then divide by 4 to get x by itself. So we've got x equals 3/4 there. So 10 and 3/4, where's that down here? Right here in the lower left corner. So I'm putting only down in that spot. This next one, this is already factored. So let me set 3x plus 2 equal to 0 and also 3x minus 2. First equation, I can subtract the 2 and then divide by 3. So x equals negative 2/3. And we do the same kind of deal over on the right side here, except now we're adding 2 and still dividing by 3, so positive 2/3. So positive negative 2/3, that's going to be over here in the upper right. So bank is what I'm banking over there. Alrighty, same strategy here as the last 12 problems. Set each factor equal to 0. So 9x minus 2 equals 0, and 5x plus 1 equals 0. For the 9x minus 2, I can add 2 to both sides and then divide by 9 to get x equals 2/9. Over here, I can subtract 1 and then divide by 5 to get negative 1/5. And those two answers, I see those right here, so that's going to be a because going right there. On this one, I can set 2x plus 2 equal to 0 and also 7x plus 6. So this first one, let me subtract 2. And then negative 2 divided by 2 gives me x equals negative 1. Over here, subtract the 6. Dividing by 7, I have to use a fraction, so negative 6 over 7. And it looks like that's right down below right here, so that's going to be escaped. Next up, we got this one. So 2x minus 5 equals 0. We can set that up, along with 3x plus 1. Over here, we can add the 5. And divide by 2, so x equals 5/2. And then if we subtract 1 and divide by 3, we have x equals negative 1/3. So 5/2, negative 1/3, that's right here toward the top. That's going to be a reason, the reason. On this one, I can set each of these factors equal to 0. Doing so for the first factor gives me the equation x equals 0, which just as soon as I write it, I've already solved it, so that's nice. We also have 4x plus 7 equals 0. Subtract the 7. Divide by 4, we have x equals negative 7/4. So 0, negative 7/4. That's going to be down here in the second row. So that's going to be robbers going down there. So for this problem, we have 1, 2, 3 factors to set equal to 0. If I set the first one equal to 0, that actually solves an equation, which is pretty cool. And then we have 2x plus 1 equals 0, and x minus 6 equals 0. So for the second one, we can subtract 1, divide by 2, so that's negative 1/2. And then just add 6 for this last one. So we have 0, negative 1/2, and 6. That's all down here at the bottom, so this is going to be a place down here. For this next one, let me set each of these factors equal to 0. So 2x equals 0, 4x minus 8 equals 0, and x plus 1 equals 0. Going through and solving each of them individually now. If 2x equals 0, dividing both sides by 2 gives me x equals, well, still 0, so that's nice. Over here, I'm going to add the 8, divide by 4, so x equals 2. And here we just have to subtract the 1, so minus 1. So 0, 2, and negative 1, that's over here. There's not a lot of these left now. They're easier to find, so that's Canada over there. Right, now we're trying to solve Toronto, apparently. So set each of these factors equal to 0. So 7x, 3x plus 5, and 5x plus 2 all equal 0. If 7x equals 0, dividing by 7 gives me x equals 0. For the next one, we can subtract 5, divide by 3, so negative 5/3 for that x value. And for the last one, we can subtract 2 and divide by 5, so negative 2/5 for that. So we got 0 and a bunch of fractions. There's only 2 left to choose from. Down here, bottom right, that's Toronto. We've got one more question, and I think we know where this is going to go, but let's play it out here. So set each of these factors equal to 0, x minus 9, x plus 1, and x minus 1. So for the first one, we add 9, that's x equals 9. Subtract 1 for the next equation, so x equals negative 1. And then add 1 for the last, so x equals positive 1. And, not surprisingly, we find all of those in the one remaining blank spot, which is where we're going to put the word run. Now that I've filled in all the words, I can actually read out this riddle here. The reason why escaped bank robbers always run to Canada is because that is the only place they have Toronto, like to run to. Wow, that is the soul of wit right there. Till next time, Mr. Sutton, signing off.